Student, in the last lecture we have seen that examples in question number 9 and 10. Now we will take examples in question number 11 and another here. So the first example in question number 11, if function f of x equal to 24 raised to x minus 8 raised to x minus 3 raised to x plus 1 divided by, or in the denominator, 12 raised to x minus 4 raised to x minus 3 raised to x plus 1 for x is not equal to 0, and for x equal to 0 function is, the value of function is given, it is k is continuous at x equal to 0, find k. So here we have to give an f of 0 equal to k here, and then we have to apply a limit to this function as x tends to 0 here. So given f of 0, function of that point equal to k, call equation first. Now we apply limit as x tends to 0 to this function. Limit of function f of x as x tends to 0 is equal to limit as x tends to 0, 24 raised to x minus 8 raised to x minus 3 raised to x plus 1 divided by 12 raised to x minus 4 raised to x minus 3 raised to x plus 1. Okay, so here we take a common 8 raised to x from these two terms and minus sign to these two terms. So when we take common 8 raised to x from these first two terms, so it remains 3 raised to x here, because 8 3s are 24, and here it is 1. We common take 8 raised to x. Now take minus common from these two terms. So it is 3 raised to x minus 1. Now here it is minus 1, minus 1. In the same, we take common 4 raised to x from these first two terms and minus 1 common from the last two terms. So when we take 4 raised to x common from these first two terms, it remains 3 raised to x and it is 1. 4 raised to x into 3 raised to x, it is 12 raised to x, and 4 raised to x into minus 1, it is minus 4 raised to x. And take a minus 1 common from these last two terms, it remains minus 3 raised to x plus 3 raised to x minus 1 here. Now we take common 3 raised to x minus 1, 3 raised to x minus 1 from numerator and also denominator here. So when we take common 3 raised to x minus 1 common from the numerator, it remains 8 raised to x minus 1. And when we take 3 raised to x minus 1 common from the denominator here, it remains 4 raised to x minus 1. Now we apply limit each and every term separately and divide numerator and denominator by x here. Numerator and denominator by x square here, because there is multiplication, or x square. So therefore it gives limit as x tends to 0, so 3 raised to x minus 1 upon x into 8 raised to x minus 1 upon x, because we divide x square by numerator and also denominator. So x into x, it is x square. In the same way, in the denominator here, 3 raised to x minus 1 upon x into 4 raised to x minus 1 upon x. Now we take a limit separately to each and every terms. So it is a left hand side is a limit of function f of x as x tends to 0 is equal to limit of 3 raised to x minus 1 divided by x as x tends to 0 into limit as x tends to 0 8 raised to x minus 1 divided by x whole divided by limit as x tends to 0 of this function into limit as x tends to 0 4 raised to x minus 1 upon x. Yes. Now by using this formula here, since a raised to x, limit of a raised to x minus 1 as x tends to a or x tends to 0 here, upon x it gives log a, it gives log a. By using this formula here, a means here it is 3, a means here it is 8. Yes, and so therefore it is log 3 into it is log 8 by using this formula divided by log 3 into log 4 here. This is log 4, this is log 3. Now log 3 will get cancelled. It is only log 8 divided by log 4. So we write here this log of 8 here, so it is 2 cube, and also this log 4 log of 2 square. Now by using rules of logarithm, it is 3 log 2 and in the denominator is 2 log 2. Since log of m raised to n is equal to n log m. Yes. So this log 2 will get cancelled. It is 3 by 2 only. So limit of that function as x tends to 0 is equal to 3 by 2. Call equation second. Since function is continuous at x equal to 0, since f is continuous at x equal to 0, it means that limit of that function equal to function of that point, means f of 0 or function of that point equal to limit of that function as x tends to 0 by 1 and 2. F of 0 by 1 is k and by 2 it is 3 by 2, limit of that function by 1 and 2, by 1 and 2. And so therefore in this way we have find the value of k here by using this limit of the function, by using this continuity of the function. Now the example number 3rd. If function f of x equal to sin 2x upon 5x minus a for the interval x is positive, x is greater than 0. For x equal to 0, the value of the function is given 4, and for x is less than 0, the function is x square plus b minus 3 is continuous at x equal to 0, then find the value of a and b here. So since here we have to give f of 0 is 4, given f of 0 equal to 4, call equation first. Now we take this interval. For this interval, for x is greater than 0, the function is sin 2x divided by 5x minus a. So since x is greater than 0, we apply right hand side limit to this function on both sides. Is equal to as x tends to 0 plus. So therefore here Since the angle of sine is 2x here and in the denominator is here 5x, so that's why we add this here 2 here. Two x divided by 2x into 2 by 5 here. We take this 5 in this side and we add just 2 here because the angle of sine is 2x, that's why. We divide and multiply 2 and we write this 5 minus a here. Now apply limit. So 2 by 5 is a constant thing before the limit. So limit of sine 2x upon 2x as x tends to 0 plus minus e. Yes, it is a constant. Limit of a constant is constant. So use 2 by 5 into value of this limit is 1 because the limit of sine theta upon theta as theta tends to 0 it gives 1 minus limit of a constant is constant. Since sine theta upon theta as theta tends to 0 it gives 1. So it is 2 by 5 minus a, call equation number 2nd. So this is the right hand side limit of the given function. Now we take this third interval. For the interval x is less than 0, the function is equal to x square plus b minus 3. So since x is less than 0, we apply left hand side limit to this function. F of x as x tends to 0 minus x square plus b minus 3. Apply limit directly. So it is 0 plus b minus 3. So it is b minus 3. So the left hand side limit is equal to b minus 3. Call equation number 3rd. Since the function is continuous at x equal to 0, since f is continuous at x equal to 0, it means that function of that point is equal to left hand side limit, or take right hand side limit, is equal to left hand side limit of that function. So by 1, 2, 3, by 1 here we write f of 0 is 4, by 2 we write right hand side limit is 2 by 5 minus a, and by 3 this left hand side limit is b minus 3, by 1, 2 and 3. So we take this 4 equal to 2 by 5 minus a and 4 equal to b minus 3, or and. So therefore take this a in the left hand side, this plus a, and take this 4 in the side, and take this minus 3 in the right hand side. So it is 5 4s are 20, 2 minus 20 divided by 5 a, and 7 equal to b. So minus 18 by 5 is a and b equal to 7. Hence we have to find the value of a and b if given the function is continuous at x equal to 0. Now the next question number 12. Discuss the continuity of the function f on its domain where the function is in modulus x plus 1 for x is less than equal to 2 and greater than equal to minus 3, and the second function modulus x plus 5 for x is less than or equal to 7 and greater than 2 here. The domain of the f domain of function f is -3, 7. So this is the domain of the given function f. Since here in modulus x plus a is continuous, this type of function here x plus a modulus function is continuous for all x belongs to R. This modulus function is continuous for all x belongs to R. So we need to consider continuity the continuity of function f at x equal to 2 here. So we need to prove this continuity of this point, continuity at x equal to 2. So therefore continuity at x equal to 2. So first of all, first interval, for the interval x is less than equal to -2 plus 2 and greater than equal to -3, the function is here modulus x plus 1. So it means that we check the continuity at x equal to 2. X is less than equal to 2 means first of all less than or equal to 2. So we have to find f of 2, function of that point is equal to 2 plus 1. 2 plus 1, and so which is 3 here. Now x is less than equal to means we apply left hand limit to this function. Is equal to 2 plus 1 is also 3 here. So therefore now we check the continuity for this interval. For 2 less than x less than equal to 7, the function is in modulus x plus 5. So therefore since x is greater than 2, we apply right hand side limit to this function. So it is 2 plus 5. 2 plus 5. Yes, it is 7. It's just 1 minute. In the second function, there is a minus sign here, x minus 5. That's why there is a correction. So x minus 5 here. Yes. And so that's why it is 2 minus 5, it is a minus 3. In modulus, it is minus 3. So minus 3 in the modulus, that's why its value is also plus here, because it is in modulus. So the right hand side of the function is 3, call equation 3. So from 1, 2 and 3 here. From 1, 2 and 3. So limit of the function of that point is equal to left hand side limit is equal to right hand side limit, and therefore it is equal to 3 here. Therefore f is continuous at x equal to 2 and hence function f is continuous. F is continuous on its domain -3, 7. Now the next question, question number 15. Show that there is a root for the equation 2x cube minus x minus 16 equals 0 between the 2 and 3. So let this function f of x equal to 2x cube minus x minus 16. Actually, this f of x, since f of x is a polynomial, and hence it is continuous for all x belongs to R, and therefore we find this f of 2 and f of 3 here. F of 2 equal to here 2 into 2 cube minus 2 minus 16, and so it gives 2 into 8 minus 2 16. It gives 16 minus 2 minus 16. It is minus 2. And also we find f of 3. So this root 2 into, put the value of 3 in this equation, x equal to 3. 3 cube minus 3 minus 16. So it is 27 minus 3 minus 16. So it is 54 minus 3 minus 16. So 54 minus 19. So it is 35. F of 3 is 35 and f of 2. Yes. And since this 0 is less than 35, it is a positive and it is a negative. Minus 2 is less than 0 and 35 is greater than 0, and therefore since this 0 is less than 35 and greater than minus 2 here, and therefore, but minus 2 is f of 2 less than 0 and 35 is f of 3, and hence f is continuous on this closed interval 2, 3. Therefore, by the intermediate value theorem. For the continuous function, there exists a point C belongs to this interval such that this f of C equal to 0, and therefore this function 2x cube minus x minus 16 equal to 0 has equal root, has a root between 2 and 3. Hence we have to show that the equation, there is a root for the equation between 2 and 3 here. So in this way, remaining example you may try to solve at home, So the chapter is over. So today we will stop here.